are in the Paul Scherrer Institute. It's a big research facility in Switzerland. And here there are many experiments around that do research with all sorts of particles, with like neutrons or protons and muons. And we are standing in front of one of the experiments. This is the one that I helped to design. And this experiment measures a fundamental property of neutron, which is its electric dipole moment. The question that we ultimately want to answer is, why is there more matter than antimatter in the universe? At the moment we don't know a mechanism that could create this asymmetry between the two variations of matter. But we think that one of the reasons may be the electric dipole moment of the neutron, one of the constituents of the atomic nuclei. So we know that neutron has no charge, but it might be that it has the same amount of positive charge, which is, say, a bit more on the top of the particle, and the same amount of negative charge, which is a bit more over the bottom, which creates this asymmetry that may have contributed to the creation of more matter and antimatter in the early universe. This measurement is extremely sensitive to magnetic fields. And it's so sensitive that even cars passing on the nearby road would actually made it not possible if not for all the shielding that you see here in the background. What I did is I designed an active magnetic shielding system that helps to keep the stability of the magnetic field on the level that makes this experiment possible. Well, in principle, it's a childhood's dream, isn't it? It's all about the curiosity for me. So I've always was curious about things, wanted to know how things work, went to disassemble and look inside the inner workings, and I think this is the pinnacle of curiosity, to try to find out about the fundamental properties of the universe. Well, I'm very honored to have gotten the CHIPP Prize, as for me it's a token of appreciation to all the work that I did during my PhD thesis. So since I've finished my PhD thesis, I've changed fields, and now I work in medical X-ray imaging, where I try to build a machine for imaging human breast for diagnosis of breast cancer.